At one point or another, you might have heard that only a few centuries ago, people thought the Earth was flat. People believed that if you sailed too far out, you would reach the literal edge of the world and fall off. Well, this is quite misleading, as people have known the Earth to be spherical since the time of ancient Greece. The earliest known evidence for the concept of a spherical Earth can be traced back to Greek philosophers during the 6th century BC. A few centuries later, no educated person thought the world was anything but round. This idea slowly spread and gradually became accepted as fact all across the globe. And while some cultures held on to the flat Earth idea for quite a while, by the time of the Middle Ages the Earth was most definitely a globe. Medieval books and illustrations repeatedly make the point that the Earth is round and not flat. The confusion actually comes from historians looking back and misinterpreting certain events and literature. While people may not have believed the Earth to be flat as much as we thought, for the longest time we definitely believed ourselves to be the center of the universe. It's called the geocentric model, and it actually makes a lot of sense. From our point of view down here on the surface, it actually looks like the sun, moon, visible planets and distant stars orbit around a stationary Earth. It wasn't until the late 16th century that the geocentric model was gradually superseded by the heliocentric model, where the sun is the center and the Earth is simply one planet among many orbiting around it. Earth is the only planet not named after a Greek or Roman god or goddess. The name comes from old Germanic words such as Eartha and Ert, and while its name is of course different in every language, what they all have in common is that almost every name derived from a word that means soil or ground. For example, here in Sweden the planet's name is Jorden, and the word for soil is jord. The Latin names Terra and Tellus can also be used as synonyms. We all know that one day here on Earth is 24 hours long, and the reason we have days in the first place is because the Earth is rotating on its own axis while orbiting the Sun. But if we do the calculations, we find that for the Earth to make one full revolution, it only takes 23 hours, 56 minutes and 4 seconds. This is called a sidereal day, and is actually not the way we calculate one full day here on Earth. This is because the unit of time known as day also has to account for the orbit around our sun. Let's take this specific point on Earth. Now let's simulate a day passing by rotating the planet. Once the point reaches the same position, one sidereal day has passed, or 23 hours, 56 minutes and 4 seconds. What makes a solar day 24 hours long is the location of this spot relative to the sun. While the Earth has definitely made a full rotation, it also moved a bit in its year-long orbit around the sun. Therefore, it actually needs to rotate a bit more, so that this point is now facing the sun like it did when it started. And just like a day isn't really 24 hours long, a year isn't really 365 days long. The reason for this is not the same, however. We count days based on the rotation of the Earth, while the year is based on the orbital period around our sun. And this is the problem. The day-night cycle has nothing to do with the yearly cycle, yet a year is determined by the day-night cycle. This results in one year being 365.2425 days long. This is where leap years come into play. Every 4th year we squeeze in an extra day at the end of February because the Earth's spin and the Earth's orbit around the sun ever so slightly overlap. Without leap years our calendars would get confused and summer would eventually be winter and vice versa. Liquid water is a crucial part for all life here on Earth, yet the origin of our planet's water remains unclear. More specifically, why do Earth have so much more liquid water compared to almost every other body in the solar system? I say almost every other body because one of Jupiter's moons, called Europa, may contain more than twice as much liquid water found here on Earth, even though it's smaller than our moon. This subsurface ocean is trapped under a vast sheet of ice and could potentially contain life. While life may or may not be so abundant in the universe, the Earth is truly teeming with it. It is everywhere and seems to somehow survive everything. Top of Mount Everest, no problem. Bottom of the ocean, of course. At the edge of the atmosphere, sure. Inside NASA and ESA clean rooms which are meant to be sterilized inhospitable environments. Are you even fucking trying, mate? What I'm saying is that life, finds a way. It truly does. Let's take a walk outside and bring a spoon with you. Good. Now dig up some soil and take a look at it. This spoonful of soil contains more living organisms than there are humans on this planet. Soil is a paradise for tiny creatures eating and pooping and reproducing their way towards glorious soil fertility. Luckily we can't see any of that, otherwise I would have flipped my shit by now. In an equally mindfuck fashion, for every grain of sand on Earth, there are roughly 10,000 stars in the universe. Welcome to Earth. Texas. The only city on Earth named Earth, well, at least in English. It has a population of around 1,000 and was originally called Fairlawn. However, they soon learned of another city by that name, so the townspeople sent in suggestions for a new one, and thus Earth became the first Earth on Earth. Most of us know that Mount Everest is the tallest point on the planet. Well, no, it isn't actually. It's only the highest mountain by elevation above sea level. The tallest point on Earth, has either the greatest distance from the center or the least distance to space, is Mount Chimborazo. This is because the Earth is not really a perfect sphere but something called a spheroid. This basically means that the Earth is a bit thicker along the equator compared to the poles. And as Mount Chimborazo is very close to the equator, it just barely beats Mount Everest. The Earth has been the home to every living thing in the universe that we know of. But why is that? If the universe has existed for so many billions of years, why is space so seemingly empty? Well, that's not exactly what this video is about, and I have in fact talked about this in numerous videos before, but a possible answer or perhaps clue to that question is the Earth itself. Because Earth is extremely complicated. Its creation and what led to our existence is nothing short of an accident, or rather a very long list of accidents. It all started roughly 4.54 billion years ago when our solar system was nothing but a gigantic cloud of dust and particles known as a solar nebula. Due to gravity, things eventually started spinning and the sun began to take form in the center while planets and smaller bodies formed around it. Out of sheer luck, the Earth formed at just the right distance so it would not be too hot or too cold for us humans to exist many eons later, the so-called habitable or Goldilocks zone. We were also fortunate enough to have a bro like Jupiter to catch many nasty comets that could potentially hit the Earth and annihilate us, much like what happened to the dinosaurs. Early in its evolution, the Earth was a hellish planet with intense volcanism and frequent collisions with meteorites and other bodies. One of these collisions is believed to have created the Moon. The Earth collided with a body the size of Mars, which ejected enormous amounts of debris into orbit. This debris eventually clumped together to form the Moon. Not only that, but the collision itself is thought to be responsible for tilting the Earth at an angle, giving us seasons. All the volcanic activity during this period began the creation of Earth's atmosphere. In turn, the comets brought with them ice that melted and helped to cool this hellish landscape to create the Earth's crust and possibly the oceans. Roughly 3.8 billion years ago, the Earth had cooled enough for life to take form. However, it wasn't until 2 billion years ago when photosynthetic life began to appear, enriching the atmosphere with life-essential oxygen. We still don't know how life began on this planet, but it's quite evident that a lot is required for it to begin. You can't just have an Earth-like planet and expect that to be enough. Of course, this is all assuming that an Earth-like planet is required for life to exist. Oh, and 63 Earths can fit inside Uranus. On the 18th of September 1846, French mathematician Urbain Le Verrier sent a letter to the Berlin Observatory. The letter contained a precise mathematical prediction of a previously undiscovered 8th planet in the solar system. A few days later, within 1 degree of its predicted location, Neptune was discovered. Leverrier was able to predict its location and existence based on the seemingly inconsistent orbit of Uranus. But something still didn't quite add up. Uranus' orbit still showed slight deviations from what was to be expected. This led some to speculate that there could be yet another planet beyond the orbit of Neptune. This potential 9th planet received the nickname Planet X. And in 1930, it was announced that it had been found. But Pluto was not what we expected to find. It was so tiny, both in terms of mass and size. So tiny in fact that it could not account for the orbital irregularities of Uranus. It wasn't Planet X. In 1989, the space probe Voyager 2 made a flyby of Neptune. New calculations based on the information it collected revealed that the orbits of Uranus and Neptune were just fine. It turns out that the perceived anomalies in Uranus' orbit was the result of not having sufficiently accurate measurements. There was no need for a Planet X, as everything checked out. In hindsight, the discovery of Pluto was completely accidental. While a certain fascination for the elusive Planet X continues to persist, most astronomers agree that its existence is unlikely. That is until just a few months ago, when new evidence came to light, which yet again opens up the possibility of a 9th planet in the solar system. And this time, the evidence is actually quite compelling. By studying multiple trans-Neptunian objects with extreme and atypical orbits, two scientists have found a strange pattern. This pattern, or orbital clustering as they call it, has about a 1 in 15,000 chance of being a coincidence. It's much more likely that a so far undiscovered planet roughly the size of Neptune has gravitationally influenced these distant bodies, leaving this orbital clustering in its wake. This potential Planet X would have such an extreme orbit that it would take roughly 15,000 years for the planet to orbit the Sun only once. To put that into context, 1 year on this planet would see the release of a staggering 2 fresh installments in the Half-Life franchise. Researchers estimate that if they are correct, they could visually confirm its existence within the next half-decade. You see this tiny red dot? That's a planet, an exoplanet orbiting a star 97 light-years away. And this is a star 129 light-years away with an entire family of at least 4 exoplanets. These photos and others just like them are the best images of exoplanets captured to date. The best image of a star, other than the Sun of course, is this photo of the star Altair, which is roughly 17 light-years away. It rotates at such a high velocity that instead of being spherical, it's gained a flattened oval shape. Before the International Space Station, there was another space station between 1973 and 1979 called Skylab. Unlike the modular construction of the ISS, Skylab was constructed and launched as a single completed unit, much like the other space stations at the time. The interior of Skylab was so enormous that there was actually a viable concern that astronauts could find themselves stuck in the middle of the station with nothing to grab onto. They would simply have to wait for minor air currents to push them towards a wall or request help from a crew member. However, they later found that they could just swim if they had to, pushing air with their hands to create a very minor amount of thrust, which allowed them to slowly move around. Getting stuff into space using rockets is, as you've likely heard many times before, incredibly inefficient. The amount of fuel and thrust you need depends on the mass of the spacecraft. But the more fuel you take with you, the more massive the spacecraft becomes, and thus you need even more fuel. But then the spacecraft gets heavier, so you need more fuel, thus adding more mass to the spacecraft and thus requiring even more fuel. In other words, there's a limit to what rockets and chemistry can provide. It's pretty insane when you first realize that when this space shuttle reaches a stable orbit, it's lost more than 85% of its mass, because 85% of its total mass was fuel. More fuel is needed to get from the surface to orbit than to get from orbit to the surface of the moon. It's been estimated that if the Earth was 50% larger, we would not be able to venture into space at all. Not using rockets anyway. I mean, the reason NASA and the Soviet Union began using rockets was to get to space first. It wasn't about long-term efficiency or sustainability. It was all about winning this global contest of firsts. And rockets were great for that purpose, but once we started thinking of going to Mars, establishing colonies on other bodies, building giant space stations and the like, we ran into some problems. The ISS, for example, is possibly the most expensive single thing ever constructed at an estimated cost of $150 billion. Many other methods have been proposed, of course. A space elevator, space plane, nuclear pulse propulsion, mass drivers, launch loops, beam-powered technology, skyhooks, a space tower, space gun, balloons, and the list goes on and on. Each and every one has its own unique set of advantages, disadvantages, and problems we may have yet to solve. But it's kind of funny when you think about it, because we've done some amazing things. We've walked on the moon, we've visited and landed on multiple planets, moons, and other celestial objects. We've built a space station as large as a football field, and we can detect other planets orbiting other stars that have the potential to sustain alien life. Yet this insignificant expanse of about 100 kilometers or so remains as one of the biggest obstacles to space exploration. The Curiosity rover on Mars landed on the Red Planet on August 5th, 2012. One of its many objectives is to dig up and analyze the Martian soil. To do this, an onboard instrument abbreviated as SAM will resonate at different frequencies so that the soil can pass through various filters for analyzation. And it sounds like this. Now, to celebrate the rover's one-year anniversary on the planet, scientists at NASA thought it would be fun to use the very same instrument to play the Happy Birthday song, which gotta be the saddest and most depressive celebration in history. Given a certain pronunciation of a certain planet named Uranus, Uranus has been the butt of a joke ever since it was first named. Even I can't resist at times. Oh, and 63 Earths can fit inside Uranus. Both pronunciations are correct, by the way, but astronomers and most of the scientific community seems to prefer Uranus over Uranus. My personal preference is your mom, but it could have been much worse. Consensus on the name for the planet was not reached until almost 70 years after it had been discovered, because the guy who discovered the planet wanted to name it Georgium Sidus, which means the Star of George, in honor of King George III. In other words, Uranus could have been named George. Besides humans, many other animals has ventured into space. Many of you have likely heard of the dog Laika. She became the first dog to orbit the Earth back in 1957. However, the very first animal in space were fruit flies aboard a rocket launched in 1947. In 1949, the first monkey was sent into space, and in 1950, the first mouse was sent into space. By the late 1960s, many other animals like hamsters, turtles, rabbits, cats, frogs, goldfish, various insects, etc. had been launched into space as well. The result of these experiments has been crucial to our understanding of both the short-term and long-term effects of living in space, not just for humans, but for the animals themselves. For example, in 2008, researchers found that cockroaches that had been conceived in space became faster and stronger than their Earth-dwelling siblings. Many birds will never be able to survive in low-gravity environments, as they actually need gravity to swallow food. Humans don't, but when the US and the Soviet Union first sent people into space, they had no idea if weightlessness could somehow impair our ability to swallow. If that had been the case, the first human in space could possibly have died from asphyxiation or starvation.
That's one small step.
This quote by Neil Armstrong as he takes his first steps on the surface of the moon is possibly the most misquoted quote in recent history. According to Armstrong himself, he didn't say one small step for man, but actually said one small step for a man. Something the world, newspapers and listeners at home back in 1969 completely missed. And if you think about it, it doesn't make much sense. He would basically be saying that's one small step for mankind, one giant leap for mankind. But there's no audible A in the recording.
It's one small step for man. It's one small step for man.
Then again, there's a lot of noise which makes it difficult to hear exactly what is being said. Maybe he thought he said for a man but accidentally fumbled his words, or maybe it's simply obscured by the noise. Given the fact that all the gas giants in our solar system has rings, one would assume that planetary rings are quite common in the universe. So far we've found over 2,000 exoplanets, but as far as we can tell, none of them have rings. Except one. And it's truly an exceptional exception. It's called J1407b and was discovered in 2012. The rings around this planet have an estimated radius of 90 million kilometers. Saturn's rings are tiny in comparison with a radius of less than 500,000 kilometers. If we replaced Saturn with J1407b, its rings would be more prominent and brighter than the moon in the night sky. It's common knowledge at this point that the main driving force behind early space exploration was the fierce competition between the two Cold War rivals, the Soviet Union and the United States. In the midst of this looming fear of global nuclear war, and with the world as their audience, these two superpowers wanted nothing more than to win. In 1962, US President John F. Kennedy addressed the nation in a now famous speech.
We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
The Soviet Union had already beaten the US in many significant milestones. The first satellite in space, the first photo of the far side of the moon, the first human in space, and the first flyby of another planet. Putting a man on the moon would surely gain the US a clear lead in this escalating space race. And as we all know, in 1969, Kennedy's promise came true. But on September the 20th, 1963, Kennedy made a very different speech.
I include among these possibilities a joint expedition to the moon. Why, therefore, should man's first flight to the moon be a matter of national competition? Why should the United States and the Soviet Union, in preparing for such expeditions, become involved in immense duplications of research, construction, and expenditure? Surely we should explore whether the scientists and astronauts of our two countries.
He proposes that the US and the Soviet Union should join forces in their efforts to reach the moon. Initially, the Soviet Premier Nikita S. Khrushchev rejected Kennedy's proposal. After all, this was at the height of the Cold War. Unsurprisingly, any form of collaboration between these sworn enemies would be met with strong opposition. Many decades later, it was revealed by Khrushchev's oldest son that his father had had second thoughts. Khrushchev had supposedly changed his mind and was in early November of 1963 ready to accept Kennedy's offer to convert the Apollo lunar program into a joint project between the two superpowers. He believed, just like Kennedy, that both countries could benefit from a collaboration rather than a competition. The Soviet Union had far better rocket technology than the US, and the US had more advanced computers than the Soviet Union, not to speak of the economical benefits of a joint mission to the moon. On November the 22nd, 1963, President John F. Kennedy is assassinated. Because Khrushchev doesn't trust the new president, Lyndon B. Johnson, all plans for a joint mission to the moon dies along with JFK. The story is fascinating because it had a potential to change history forever, not just in terms of space exploration, but it would surely have improved US-Soviet relations. Just imagine how different the world could have been if astronauts and cosmonauts had stood on the moon together.